Okay, the next lesson is going to continue to talk about more angles created by transversals. Remember, a transversal is a line that crosses two or more lines. So this happens, and especially when this line crosses two lines that are parallel. Now we know these lines are parallel because they have these little triangle marks right here. They're supposed to be triangles, and it creates some angles. So like alternate interior angles say that, you know, one line that's on one side of the transversal and an angle that's on the other side of the transversal, as long as they both are on the inside of this interior, so they alternate across the line and they are inside the transversals, okay, they are congruent. And congruent, remember, means the same size and shape. So in this case, they have the same measure, okay? Same measure. I could spell that correctly, it'd be nice, huh? Same measure, okay? So look in this problem. Suppose A, it has a measure of 48 degrees. So 48 degrees. Show what you know about angle pair relationships to determine the measure of angle B. Well, I could prove to you that this is also 48. You can take my word for it, but if we check this out, do you see right here, these angles here make a linear pair. So then that means that this one is going to be 132 degrees. How did I get 132? 180 minus 48 equals 132. And then if we notice and look a little bit closer, these angles here, this one that's 132, and this angle down here is also 132 because they're sitting in the same position. We already talked about corresponding. So I'm going to shade that in red. The red angles are corresponding angles. Okay, they're sitting in the same position. Okay, if they're sitting in the same position, so these red angles, they're both 132. Well, if that's the case, then we can go here and we can see that this 132 plus our angle B, that makes another rainbow or linear pair, and then that means that linear pair adds up to 180. So 180 minus 132 equals 48 degrees. So we just proved that the measure of angle B equals 48 degrees. All right, so your job is to understand that the relationship between angle A and angle B are alternate interior. They alternate across, or they switch across the transversal, and they're both on the inside of those parallel lines. Okay? All right, so here we're going to go to the next one. Same side interior. Well, obviously, same side, they're on the same side as the transversal, and then again they are on the interior. Well, if we say that, let's see what their relationship is. FCD. FCD, we're told that that one's 57. Okay, then find the measure of FCD. It says it's 57 degrees. This is obviously not drawn to scale. Find the measure of CFG. Okay, so what is this one? Well, again, we can see that FCD and then this one down here are corresponding. They're in the same position. Bottom, right, so 57 and 57. And then guess what? These two make a linear pair. So we're going to go 180 minus 57 is 123 degrees. So this makes what? 123. So then we can find out that the measure of angle CFG equals 123 degrees. And this is going to work out for every same side interior angle. Same side interior angles are supplementary. You probably want to see what I'm writing because I have the camera kind of low. Let me back that up again. Or supplementary. Supplementary, remember, this is my little reminder that it adds to 180 degrees. And then another little clue is, look at same side begins with S. It's nice how everything like that happens in geometrical problems. All right, so those are the two types of angles we're going to focus on. We're adding those to the ones we've already learned about. Remember, we've already learned about corresponding angles. Just to look back at yesterday's note, corresponding angles, that's an important one. That's the ones that are in the same position. And then the other types of angles that we have already talked about, just as a reminder on our first page of notes, understanding that complementary is 90, supplementary is 180. Vertical angles are the ones that make a V, so I make a V this way and a V that way. And then congruent angles, we're still talking about that. Those are angles with the same measure. Okay, so when we go here to our practice, let me make sure this is all in the camera for you. Let's see what's happening. Use the diagram at the right. Name the angle pair relationship. So what is their relationship? Well, let's see. What's the first one say? D and E. So here's D and here's E. Okay, so they're both on the inside of the two lines. Now notice this problem, they're not parallel. So that means that D and E are not going to be the same length, but they can still share the same relationship as either same side interior or alternate interior. Well, it's kind of cool if we're just talking about two types of interior angles, interior, there's either one that alternates across the line or one that's on the same side. So it's pretty cool. We just only have to focus on two different ones right now. So this one, because it's on different sides, must be alternate interior angles. This is my little abbreviation for alternate interior angles. What about E and H? E and H. Okay, so H is over here. Now they definitely alternate across the line, but they're both not on the inside. So if I remember about the different kinds of angles and I look at my notes, I see that there's forms of V here and a V here. So V for vertical angles. Vertical angles. So this is an angle sign with a little arc mark across it so that it doesn't look like a letter L. It helps me just distinguish that it's not an L. And then apostrophe S for vertical angles. Okay, A and E. Okay, A and E. Let me highlight these because I'm getting too much purple in our little picture here. A and E, arts and entertainment. A and E. Let's see. They're on the same side, but they're both not interior, so there can't be same side interior. But you see how this is in the top left of this group of four, and this is the top left of this group of four? So that tells me that they're sitting in the same position, so they are corresponding. And when you do your homework, and you're on Delta Math, go ahead and have your notes out and look at these words until you get used to them. Okay, let's look at C and D. C and D are right here. C, I could see just by making my little arc marks or my little angle notation that I made an upside down rainbow. Rainbows, remember, happen in lovely places. So this is an example of a linear pair, and they make a straight line. That rainbow lands on a straight line, so they are 180 degrees. I'm just making a little note that linear pair is 180 degrees. Let's look at the second problem. All right, calculate all the missing angle measures in this diagram. Let's see, all the missing angle measures. Okay, no problem. Here we go. We got this. So I can see right now that I can calculate this one easily and this one easily because those are my linear pairs. So 180 minus 75 degrees equals 105 degrees. Okay, so this is 105 degrees. And now we have down here 180 minus 85 degrees equals 95 degrees. So this one's 95 degrees. All right, so let's see. Linear pair helps me do that. Do you see how this makes a V, my angle, and coming off the same vertex makes these legs that come across from it. So this is 85. I could do the same thing here. This V, this is 95. 85, these are vertical angles. I'm going to put vertical angles here in red, vertical angles. And the 95 and the 95. So I could do the same thing for at the top here. What is the vertical angle with the 75? If my V is facing this way, and when I come across it this way, this is 75, angles that are across from each other. And then I could do vertical angles, or again, I could make a linear pair right here, and then I can subtract and see that this is 105. Okay. Vertical angles are easier. Okay, they are across from each other. And they are the same measure. Okay, and let's see. If this is, if this is my transversal and it's crossing two parallel lines, then that means that this angle and this angle right here, see how the 75 and this space right here, this is the bottom left, those are corresponding. Okay, so I'm going to say that the 75 degrees are corresponding angles, so therefore they are the same measure. This little symbol right here, these little three triangles, means therefore. Therefore same measure. You can use that in your other classes too. Yeah, you all use the word therefore on a regular basis, right? So then that means I have the same, all of this is just going to be a mirror image of what's over here, because this transversal is crossing two parallel lines. So this 75 is sitting in the same position. So that's going to make this 105, this 75, and this 105. They're all sitting in the same position. Okay, so now we're going to go here. Well, is this the transversal that's crossing two parallel lines? No, because this is not parallel to that. These two are the lines that are parallel because they have the little triangles on them. So this is my transversal, and I can see this 95 is in the top right, so this is in the top right, so it's going to be the same position. 85 is the same position over here. 95, I can say that it's corresponding to this 95, or I can say it's vertical to this 95, or I can say it's a linear pair to 85 and 95, and then I'm sure you're thinking, oh, that one's also 85. All right, that is lots of information about more angles that are created by transversals. All right, this lesson is over. Log on to Delta Math and work on the assignment that corresponds to transversal angles.